Assalamualaikum. My name is Nur Suhada binti Firdaus. My matric number is 211112446. I'm a group leader for Group 19. My team is Nur Zakira, Chia Hao, Sojendran, and Hazim. Our project title is SmartMycelium IoT Temperature and Moisture Control. Now, I'm delighted to share with you the project overview. Mushroom cultivation is influenced by factors such as environmental temperature, humidity, light, and airflow in mushroom houses. Between factors of the basic needs, environmental temperature and humidity are the most important factors affecting the productivity of mushrooms. This mushroom project is a medium-scale system that consists of three subsystems, which are the power system, the watering system, and the temperature and moisture system. This project also includes industrial evolution, IR 4.0, that will cover temperature and moisture systems. This system will integrate data analytics, advanced automation, and connectivity technologies to embrace the principle of IR 4.0. This system also utilizes sensors and actuators to maintain optimal humidity levels within the mushroom cultivation environment. Real-time monitoring and automated control ensure that conditions remain conducive to mushroom growth. In addition, by using this system, users will be able to see the latest temperature, humidity, display reports, draft, the status of actuators, and the version of the system. Next, this project also contributes to Sustainable Development Goals (SDG) by optimizing humidity levels and reducing the need for manual intervention. The humidity system promotes resource efficiency and contributes to SDG 12, responsible consumption and production. Finally, by supporting sustainable agricultural practice, it aligns with SDG 2, Zero Hunger, by enhancing food security and nutrition. From project overview and some readings, the common problems faced by mushroom farmers are: first, it is difficult to control the optimal temperature and relative humidity inside mushroom sheds, and periodic monitoring had to be done. And second, the current temperature and relative humidity control system that is currently carried out is done manually. This makes it inconsistent in terms of work and time management. There is three objectives in this project. Firstly, to study and collect data related to temperature control and relative humidity in mushroom house. Second, to provide the knowledge about temperature and humidity in agriculture to the society. And lastly, to develop temperature control systems and relative humidity in the mushroom house.
Hello, let me talk about our scopes in this project. First of the point is Industrial Revolution IR 4.0 Internet of Things, as known as IoT. The first point is to detect temperature and moisture level changes in the house and alert the user. And the second point is the signal that has been received will automatically control the level of temperature and humidity in the mushroom house. It will initiate an action when the level exceeds the predetermined level. So, the third point is to collect data at regular interval, and end of each month, the system will generate a report summarizing the temperature and moisture level during the month. Okay, for the second point of our scope is Sustainable Development Goals, as known as SDG. So the first one is SDG2, zero hunger, enhancing food security and nutrition. And the second point is SDG 12, responsible construction and production, promote resource efficiency. Okay, the last part of our scope is ability to able control the temperature and moisture of the farmhouse.
My name is Nur Zakira binti Muhammad alias. In developing the SmartMycelium IoT subsystem for our mushroom farming project, I have compared three different sensors to find the best fit for managing the critical parameters of temperature and moisture, which is for controlling humidity using humidity sensor. We compared HP2O2 hygrometer humidity sensor that detect the humidity level from 20% to 95%. Secondly, we have THT22 humidity sensor module. It detects the humidity level from 0% to 99.9%. Thirdly, we compared DHT20 humidity sensor that detect the humidity level from 0% to 100%. Setting temperature inside the mushroom farm, we compared LM35 temperature sensor that have accuracy of plus minus 0.5 degrees Celsius at room temperature and plus minus 1 degree Celsius over a full minus 55 to plus 155 degrees Celsius temperature range. Secondly, we compare TMP36 temperature sensor that operates at accuracy plus minus 1 degree Celsius at plus 25 and plus minus 2 degrees Celsius over the minus 40 to plus 125 degrees Celsius temperature range. Third, we compared LMT01 2-pin temperature sensor that has flat plus minus 0.5 degrees Celsius accuracy with very fine resolution over a wide temperature range of minus 20 to 90 degrees Celsius without system calibration or hardware-software compensation. To connecting the sensor to the sensor, we are using Arduino from Arduino Uno R3. It can build programming language in a software called Arduino IDE based on C++. Secondly, we compared Arduino Mega 2560R3. It has built-in 4 hardware serial ports and can handles larger and more complex datasets. Thirdly, we compared Arduino MKR Wi-Fi 1010 that can provide significant boost for IoT with the added wireless connectivity and ability to connect to a Wi-Fi network and communicate through the internet.
It's SmartMycelium. Today I would like to talk about market survey result. Our title is about SmartMycelium IoT temperature and moisture control. Our objective to do this survey because we want to find customer needs, marketing strategies of the product, and product development of the mushroom farm. From the survey, what I can conclude was customers prioritize product in high demand. This is shown in the graph that 39.4 was consume mushroom several times a week. Next, customer respond that they definitely will purchase the mushroom if they were available in their area. This is show mushroom was high demand in the customer. Next, the customer need the size to be compact and effective. In the graph show what size are you consider for implement a mushroom farm. That show 39.4% say that they are choosing a small size which is 50 multiple 60 as their preferred size. Next, customer needs the price to be affordable. This is shown in the slide. The respondent mostly spend below 500 on this project. Next, the customer needs temperature control to withstand climate change. This is shown in the graph. 93.9% of respondents agree on the importance of moisture control system in preventing issues such as bacteria and monthly growth. Next, that show that in the graph, Demonstrate climate control has the highest peak rate compared with other options. On the graph, say that 67% say that they are agree with climate control has the highest vote for implement at the mushroom farm. Lastly, 97% of respondents agree with the statement that implement a moisture control Internet of Things prevent the issue of moisture fluctuation in the growing environment, which is 97% which agree with that.
Hello, my name is Wee Chia Hao. I'm gonna introduce about House of Quality in our project. House of Quality is the combination between customer requirement and engineering characteristics. We talk about customer requirement first. The first one customer requirement is the customer needs the price to be affordable. The second one is the customer needs the size to be compact and effective. The third one is the temperature control system needs to withstand climate change. And the last one is the customer prioritize product in high demand. So now we can talk about engineering characteristics. We have 5 different engineering characteristics that we can be concluded. The first one is decreasing the cost of the project. The second one is increasing the housing capacity of the mushroom farm, followed by the increasing of the data that can be captured. The fourth one is the increasing in the trending, and the last one is increasing the quantity of the mushroom that can be produced. So based on this data, we know that the raw score is 209. The cost have 94, housing capacity have 24, data have 23, trending have 23, and the quantity is 45. Based on this data, we can have the rank order, which the cost is the first place in the rank order, which means more of the people are more concerned about the issue of the cost. The second place is the quantity. So that means more of the respondents are concerned about the quantity of the production of the mushroom. Following by the third place, housing capacity. Then for the data and trending, both of them are fourth place in the data. So let's conclude that the cost is more of the people will concern about this issue.
Getting into the product design specification, the system is done to revolutionize mushroom farming at rural areas by optimizing temperature and moisture levels for mushroom growth. The system takes advantage of both temperature and moisture sensors to maintain optimal conditions at all times for an ideal environment for both mushroom growth and soil health. Furthermore, our system possesses several key features such as climate control integration, automated watering, cool-down systems, and alert system for predetermined thresholds. Moreover, the addition of wireless connectivity shows off its capabilities for easy monitoring and control. Secondly, going into the market identification, we have identified grocery stores, individual customers, and farmers markets as our target market, and our marketing strategy focuses on highlighting the superior plant quality and soil health benefits. Going into the financial requirements, the cost of the system costs around 427 million with a retail price of 600 ringgit. Meanwhile, there's no warranty or direct profit return on the investment. The true value actually lies in the significantly improved farming efficiency and the product quality. Diving into the physical description, our design emphasizes on compactness and space efficiency for mushroom cultivation. Besides, it was built to withstand harsh conditions. And lastly, social, political, and legal requirements. We are always committed to ensure that the workers and the health and safety of the workers at the area are safe, therefore minimizing an environmental impact. To conclude this, the system represents a cutting-edge solution for enhancing mushroom growth and preserving soil health. Thank you for your attention.